Now let's focus on learning objective E and state multiple magnitudes of rotations. Now on here, part B is actually asking us to give 3-degree measurements for this rotation. Well, there's one of them. How can you get the other one? Well, what if I go backwards or clockwise? How many degrees is that? Well, that we can get by taking the existing 135 degrees, and if we subtract a 360 degrees from it, it'll actually give us a negative 225 degrees. Now, use your gut instinct. Does it seem reasonable? This is negative 180 and a little bit more, so negative 225 makes sense. Now, where could that third measurement come from? Well, it's a circle. I can go around it as many times as I want. Why don't I go around a complete rotation? That's 360, and then do this extra 135. So here, take the 135 and add 360 to it. If you do that, you're going to get a 495 degree rotation. So we now have 3 different ways to actually land at this same spot, which is right here. The key to do this is you can add as many circle rotations to it. So I could do 2 of these, 3 of these, 4 of these. I can also subtract as many circle rotations that I want to from it. It's up to me in finding the different magnitudes that will land me at the same spot. Now you might have to page through your notes to find this slide, but let's start with this one. And it says draw a circle in the rays that shows a rotation of 7 pi over 6 radians. So now there's a couple ways that you can look at the 7 pi over 6 radians. Sometimes it's easier to make it a mixed fraction. So 6 goes into 7 once with a remainder of 1. So the mix is the same as 1 and 1/6 of a pi. So if we remember on a circle, for graphing we're always going to start here. And remember, one full rotation is 2 pieces of pi. So to move the 1 pi would be half of a circle. So that is the 1 pi. Then the other 1/6 of a pi, if you think about it here, if it helps you to visually put this into 6 different pieces, you could do that. So the 1/6 is going to be here. So the full rotation of 1 and 1/6, or 7 pi over 6, is going to land us right here. Now, what they want us to do is to give 2 other radian measurements of that same rotation. Now remember, this is going counterclockwise, which is the positive, so that's the plus 7 pi over 6. And we would just write it as 7 pi over 6. We don't actually put the plus. But we could also go backwards. So if you want to tell someone to go backwards, you can actually count this. On here, there are 1, 2, 3, 4, 5 pieces of the 6 pi's. So this would be 5/6 of a pi going backwards. So it would be negative 5 pi over 6. Now, if you're not sure where to get that from, what you can do 7 pi over 6 and subtract from it 2 pieces of pi. Now, we do want to keep it as a fraction, so you can make any whole number a fraction by putting it over 1. Remember, we want a common denominator here, so we're going to have to multiply this by a 6. So when we do that, we have 7 pi over 6 minus 12 pi over 6. Keep the denominators the same, but 7 minus 12 will get us the negative 5 pi over 6. So that'll give us a second rotation, and we do have our first one here. Now, they want a third rotation, so we have a couple options. One thing that we can do here is we can choose to go around the circle 1 complete rotation, which is 2 pieces of pi, and then go another 7 pi over 6. So for that, I would just say take 7 pi over 6 and add to it 2 pieces of pi. Again, let's get a common denominator, which is going to be our 6. So now 7 pi over 6 plus 12 pi over 6 is going to land us at 19 pi over 6 is a third possible rotation. Keep in mind, if we wanted to, we could also go backwards. We can do minus 2 pi and then go another negative 5 pi over 6. So that would be a fourth option if we wanted to. Or, you know, an infinite number of options, you can always go around the circle as many times that you want, so keep adding 2 pi's and then land over here. So the key is to add multiples or subtract multiples of the 2 pi's.